kingdom is made up of major groups, recognized by key traits. Fish have fins. Some land animals have 4 legs, others 6. And several different groups have wings. Biologists have long sought to discover how groups of animals and their key features evolved. And one of the greatest mysteries has been the origin of birds. Our world has more than 10,000 species of birds with feathered wings. Where did birds come from? And how did wings and feathers first arise? To find out, scientists have scoured the fossil record. And they have uncovered surprising twists in the evolution of birds from their flightless ancestors. In the past 30 years, we've found a treasure trove of new fossil discoveries. They've made the origin of birds one of the best documented transitions in the history of life. I'm fascinated by birds. And as a paleontologist, I've spent my career chasing their evolutionary origins in the fossil record. Above all else, what makes birds unique are their wings. They're made of feathers that are stiff yet flexible. And bird wings are even more remarkable than airplane wings because they can flap, which allows them to maneuver rapidly and ultimately defy gravity. The quest to understand the origin of birds and other animals began in earnest over 150 years ago. When Charles Darwin wrote The Origin of Species, he argued that every major group of animals evolved from a pre-existing one. He predicted that we would find fossils with features that linked one major group to another. In fact, he staked his theory of evolution on the existence of these intermediates. But no fossils were yet known that reveal these transitions. Then, just 2 years later, a marvelous creature was unearthed from a limestone quarry in Germany. The 150-million-year-old fossil named Archaeopteryx rocked the scientific world. This Archaeopteryx fossil is truly remarkable. It preserves in fine detail feathers along the wing, just like those we see in living birds, and feathers along the tail. But the bony features tell a very different story. If we look closely, we'll see teeth in the jaw, tiny claws preserved in the hand, and a long bony tail, lacking in living birds, but present in things we think of as traditionally reptilian. For Darwin, it must have been an incredible vindication. He predicted that we would find forms like these. Archaeopteryx pointed to a close link between birds and reptiles. But which group of reptiles? Flying pterosaurs have been discovered with light, hollow bones. But their wings are constructed very differently than the wings of Archaeopteryx and birds. Here is a tiny pterosaur, and if we take a closer look at its arm, we'll make out 3 small digits, and a 4th, which is really, really long. The membrane of a pterosaur wing attaches to this 4th digit and along its body and hind limb. In contrast, the wings of Archaeopteryx and birds have only 3 digits. and their feathers attach individually along their arm and hand bones. These differences tell us that pterosaurs and Archaeopteryx evolved flight independently. Archaeopteryx must have descended from different reptiles. Thomas Huxley, Darwin's champion, was astonished by Archaeopteryx's resemblance to a turkey-sized dinosaur called Compsognathus. Compsognathis's hand also had 3 digits. It had hollow bones and stood on 2 legs. Similarities like these led Huxley to propose that birds are related to the branch of reptiles called dinosaurs. But other scientists questioned this conclusion. Birds appeared so different from dinosaurs, and some characteristic features of birds, like wishbones, seemed to be missing in dinosaurs, but were present in other reptiles.
We found an articulated foot.
When paleontologist Jack Horner began his career, few thought that birds could have come from dinosaurs. So Jack, why was it so hard to believe that birds and dinosaurs were related?
Most of the dinosaurs that the public knew about were really big. Like, this is a shoulder blade of a sauropod, and sauropods were gigantic.
Scientists thought that dinosaurs were cold-blooded and slow-moving, like other reptiles.
People couldn't imagine dinosaurs being agile and hopping around. They look at these big giant things and they lumber. There's no way to relate them to birds.
Then, in 1963, John Ostrom discovered a fossil in the Badlands of Montana that challenged that view.
What John Ostrom first found was this claw. Obviously goes to a foot. It was not a claw for walking on. This dinosaur actually used that claw for slashing.
Deinonychus was small, with a delicate build. It ran upright on 2 legs. It had a long, stiff tail for balance. Not all dinosaurs were big and lumbering.
Ostrom hypothesized that the animal would scale its prey and start using its slashing claw and probably eating the animal while it was alive.
Ostrom's discovery set off a revolution. What if dinosaurs weren't slow, but warm-blooded and fast-moving, like birds? When Ostrom compared Deinonychus to Archaeopteryx, he saw that they both had lightly built, hollow bones. And they shared even more features, including long arms and similar hip and shoulder bones. Ostrom concluded that birds did descend from dinosaurs, as Huxley had argued. Not from lumbering sauropods, but from another lineage called theropods that walked on 2 legs and included T. rex and agile predators like Deinonychus.